All right, this is Mrs. Crary, and I'm going to be walking through our Unit 2 practice exam that I use to help you prepare for your Unit 2 exam. Here are the equations that we had. We had the sum of the forces equals the net force, which is equal to the mass times acceleration. That's Newton's law, second law. We know that the force of gravity is equal to mg, which is also called the weight of the object. We have equation for two different types of friction. Force of kinetic friction, which is equal to the coefficient of kinetic friction times the force normal that's acting on the block or object. The maximum static friction we know is at the quantity of the coefficient of static friction times force normal, but it could also be less than that. The maximum is always at the value use of S times force normal. However, if I'm not at maximum, I will be less than that. How do I know if I'm at maximum? It'll be just about to slip. So let's do some problems. We have a student who weighs, so there's the weight of the object, 500 newtons on Earth. Okay, so weight changes when you go to different planets, but mass does not. And then they tell you the weight of the person on planet X, and they want to know what the acceleration due to gravity is on planet X. So here's on Earth. We know that the weight is equal to 500 newtons, and the equation for weight is mass times acceleration due to gravity. So I need the mass in order to find my acceleration due to gravity on planet X. So if you go to planet X equation, 4,500 newtons equals mg. I want little g, that's what the question is. And I don't have mass, but I have enough information to find it. So I rearrange what I know on Earth, and I find the mass to be equal to 51 kilograms. And then now I can rearrange the weight equation again on planet X, and I can find that the mass is 51 because it's constant, and I will find little g to be equal to 88.2 meters per second squared. Number two is a similar problem. I have force of gravity. It is equal to 459 newtons times, which equals mass times acceleration due to gravity. They want to know what the mass is, so rearrange the equation for mass. 459 newtons divided by little g, because I'm on Earth, I find the mass to be 46.8 kilograms. What is the magnitude of the net force required to accelerate a 825 kilogram go-kart from 0 to 15 meters per second in 8 seconds? Well, I'm going to focus on what they ask for first. Sum of the forces, that's the net force. That is the net force. That's F net is equal to mass times acceleration. I know the mass, but I don't have acceleration. But I know I have another way to find acceleration. I can use my 5, 4, 3, 2, 1 equations. I know I started from rest. I know that I have a final velocity of 15 meters per second. They told me that was a time of 8 seconds. And so I will use my first equation on my equation sheet, which is straightforward, to solve for acceleration, and I'll find that to be a positive 1.88 meters per second squared. I will then plug that into F equals ma, and I will find that the net force is equal to 1547 newtons. I knew the mass. So the next problem that I'm going to solve is the net force of 225 newtons is applied to an object. As a result, the object accelerates with an acceleration of 23.3 meters per second. The mass of the object is question mark. So what they give us here, they tell me the force, right? They give me the force in the problem. That they tell me that the acceleration is 23.3 meters per second squared, and they want to know the mass. Same equation, Newton's second law. The sum of the forces equals ma. They told me the net force, so that's the only force acting on it. I rearrange the equation for mass, and I will find mass equal to the net force over acceleration. Net force was given, acceleration was given, and we can plug that into our calculator and find the mass to be equal to 9.66 kilograms. The next problem is an elevator problem. We know that a 45 kilogram person steps on a scale in an elevator. The first question asks to determine the force normal if the elevator is traveling at a constant velocity. I have to draw a picture. So here is the person standing in an elevator. Here is the forces acting on the person in the elevator. They told me that the acceleration is 0, so those two forces are identical to one another. We know that the force normal then therefore is equal to the force of gravity, and I can plug in the mass which they gave me times little g on Earth, and I will find that to be equal to 441 newtons. The next question is, they're going to change the condition. They're going to tell me that something happened to the accelerator and now force normal is no longer 441 newtons. It is equal to 510 newtons. So if you can imagine, force of gravity is not going to change because that's related to Earth. So force normal just got larger than force of gravity, so that means I'm going to accelerate. Which way? Upwards, because it's 510 newtons, which is greater than force of gravity. Sum the forces in the x direction. In the y direction. There's two forces, one in the positive, one in the negative. That equals mass times the acceleration in the y direction. Rearrange and solve for A. Plug in the values that were given to you, which was 510 newtons, minus the mass of the person, which is 45 kilograms, times little g, which was 9.8 meters per second squared. And then you'll find the acceleration is a positive 1.5 meters per second squared. You didn't even have to solve for acceleration to know that it was upward, because force normal now was greater than force of gravity, but it was upward. It's positive. If it came out negative, then it would have been downward. All right, we have a 32 kilogram crate. It's pulled along a horizontal smooth surface, no friction. It's being pulled by an 8 Newton force that is directed at 15 degrees above the horizontal. Here is the sketch, a free body diagram, and determine the acceleration of the crate. So here is my sketch right here. I have an object being pulled across a smooth surface. There's a force above the horizontal of 15 degrees. My free body diagram, there's a force normal, force of gravity, and F, and that angle above the horizontal is 15 degrees. That's 15 degrees. I then use SOHCAHTOA. There's F. I need to find Fx, and I need to find Fy. I use cosine values for f of x, so that'll be f times cosine of theta, and for y, that'll be f sine theta. And so here's what those look like now. There's one in the x direction, f cosine theta, and now I have two in the y direction, f sine 15 degrees. They want to know the acceleration. Well, in the y direction, I'm not accelerating. I will sum the forces in the x direction. There's only one force in the x direction. It's a positive f cosine 15 degrees. That's equal to mass times acceleration. So I move the mass over by dividing both sides by mass. I can now plug in numbers. I get a positive 0.24 meters per second squared. I have to be, number 7 asks me to determine the tension in the cable used to hang a 1,000 kilogram wrecking ball. The first thing I'm going to do is draw a picture. So here's a cable. The wrecking ball is in air, so that is not a force normal, but it's a cable, and therefore it's force of tension. It's just hanging there, so acceleration is 0. And so the sum of the forces is in the y direction is equal to mass times acceleration in the y direction. Since the object is not accelerating upward or downward in the y direction, acceleration is 0. I have one positive force, which is force of tension. I have one force in the negative direction, which is force of gravity, which is mg. Those equal 0. Rearrange for force of tension. I get force of tension equals mg, plug in values, and now you know the force of tension is 9,800 newtons. Very similar to finding force normal of an object sitting on a surface. Number 8, we have an object that weighs 65 newtons, is pulled on a horizontal surface by a horizontal pull. That's a very important word. 48 newtons to the right. The friction force on this object is 25 newtons. To the left, draw a sketch, a free body diagram, and determine the acceleration of the object. Here is my sketch. I have 48 newtons to the right. I have 25 newtons of frictional force to the left. Force normal is up, and the weight of the object, that's a trick there, is equal to mg, so that is the force of gravity downward. Weight is equal to force of gravity. So here's my free body diagram. Force I applied was greater than force of friction. That means I have uneven forces in the x direction, and therefore I know that I have acceleration in the positive right direction. They wanted me to determine the acceleration of the object, so I will have to sum the forces in the x direction. There's one positive in the x direction, there's one negative in the x direction. That is equal to the mass times acceleration in the x direction. I rearranged that equation for acceleration. I have, by dividing mass on both sides of the equation, I will then plug in numbers, and then I will find the acceleration to be a positive 3.47 meters per second squared. Number 9, we have a driver of a 950 kilogram car is traveling at 15 meters per second, slams on the brake and skids to a stop. If the coefficient of friction between the tires and the level road is 0.8, how long is the skid marks? Okay, we have to draw a picture. I have a car. It is traveling initially at 15 meters per second. They told me I skid to a stop, so I know the final velocity is 0. They asked me how long the skid marks were, so they're asking for delta x, and they also gave me a value of the coefficient of, that should be a k, so there's a mistake of notation. It has to be kinetic friction because the car is sliding. What is the free body diagram? Well, here's the free body diagram. I have force normal, force of gravity, and the only force that's acting on the car is the force of kinetic friction. There is no force applied because there's no engine or someone pushing it. So there we go. They want to know how long the skid marks are. So I'm going to focus on 5, 4, 3, 2, 1 first. I know the initial velocity. I know the final velocity. I was asked for the skid marks. I don't have the third item. However, we have a new way to find acceleration, which would be our third variable in our 5, 4, 3, 2, 1 equations. So I'm going to use a new skill, which is Newton's second law. So Newton's second law says the sum of the forces is equal to mass times acceleration. I'm looking at the x direction. There's only one force in the x direction. It's the force of kinetic friction. That's a mistake. Little k instead of little s. Okay, kinetic friction. It is to the left, so it's negative. We have an equation for kinetic friction. It is mu k times force normal. That's on your equation sheet. We know that force normal acting on this car is equal to force of gravity because we have 0 acceleration in the y direction. So I can then plug in for force normal the mg value. This is subscript k. So negative mu sub k times mass times little g equals ma in the x direction. Masses cancel, and we move our, then we have an equation for acceleration. Acceleration is mu sub k times little g. And I have a negative somewhere in there. Where's my negative? Oh, there it is. So there's a negative 0.8 times 9.8, and I will find acceleration to be negative 7.4 or 84. That's not what they're asking for, however. They're asking for our skid mark length. Well, now I have 3 things. So now I have the third item that is needed in the UAM equation. And what am I looking for? I'm looking for the delta x, so I have to use this UAM equation because I don't have time. I rearrange that equation for delta x. I plug in the values that are given to me, and I will find delta x to be equal to 28.7 meters. Number 10, An object slides on the level floor, it slows down and comes to a stop with a constant acceleration of 1.8 meters per second squared. What is the coefficient of kinetic friction between the object and the floor? Draw a sketch and a free body diagram before solving. So here is the sketch. I have an object. He's sliding to the right. He comes to a stop. We were told the acceleration is 1.8 meters per second squared. Well, if I'm moving to the right and I'm slowing down, my acceleration has to be to the left, so it's negative 1.8 meters per second squared. I know the initial velocity, I know the final velocity, and I know the acceleration, okay? What do they ask for? They wanted to know the coefficient of kinetic friction. The coefficient of kinetic friction is in the equation for force of kinetic friction. So in order for me to solve for the coefficient of kinetic friction, I have to find the magnitude of the kinetic friction. Well, how do I do that? I use Newton's second law. Sum the forces in the x direction. It is equal to mass times acceleration in the x direction. There's only one force in the x direction. There's the equation for kinetic friction. It's negative mu k mg is equal to mass times the acceleration, which is negative. I will then rearrange that equation for the coefficient of kinetic friction, plug in the values that were given to me, negatives cancel, and I get a 0.184, which makes sense. Mu k should be somewhere between 0 and 2, and the value of mu k should be a positive number. Number 11 and 12 look identical to one another. However, there's a very subtle difference between the two. In number 11, the box is at rest. In number 12, the box is about to slip. Okay, so number 11, I have a 42 kilogram box. It's on at rest on a horizontal surface. The coefficient of static friction between the box and the surface is 0.3. The horizontal force that somebody applied to it is 108 newtons. What is the frictional force acting on the block? So this is static friction because the block is not sliding, it's at rest. But notice they did not tell you that it was about to slip. Therefore, we do not know, it cannot assume that the static friction is at its maximum value. So we have to find it by looking at the free body diagram and summing the forces in the x direction. So I've drawn a picture. Here is the picture. It is a box that's being pushed by a force. I have a free body diagram here which shows force applied to the right, force of static friction to the left. The acceleration is 0, and therefore all of the forces in the y direction have to equal 0, added up, and all the forces in the x direction have to add up to 0. So the only force in the x direction is a positive 108 minus the force of static friction. If you rearrange that, you'll find force of static friction is equal to 108 newtons. If you use this equation, force of static friction max is equal to mu sub s times force normal, you'll find that value to be greater than 108, and that is not how we've solved that problem. We were not told that it was at its maximum. 12, however, is at its maximum. How do I know? Because it says it is starting to slip. The question gives me the mu sub s value, but it doesn't tell me anything about the force that's being applied. I've applied a force to the box. I was told it was about to slip. So we still, right about to slip, it still has an acceleration of 0. It hasn't started to accelerate yet. So we have these forces in the x direction are still equal to one another. The force applied is got to equal the maximum force of static friction. So I can sum the forces in the x direction is equal to 0. The only positive force is force applied. The only force in the negative direction is the maximum static friction. Those added together is got to equal 0. So the force applied must equal the force of static friction max. So that is equal to mu sub s times force normal. In this case, force normal is equal to mg. I can now plug in values. I don't know what happened to my thing. It is 0.3, which is mu sub s, which they gave you, 42 kilograms, which they gave you, and 9.8 meters per second squared, which is the value of little g. I don't have my calculator here, but I would assume you could plug that into your calculator and that will be your answer in newtons. One last problem to go. Number 13 is a third law problem. I have a 71 kilogram parent. I have a 29 kilogram child. They meet in the center of an ice rink. The reason why we have ice is because there's no friction. And they place their hands on each other and they push. They tell me the acceleration of the child and they tell me, again, the mass of the two. Here are the free body diagrams. I have a push from the parent on the child and a push of the child on the parent. Newton's third law states that those forces are equal. We want to know the acceleration of the parent. However, I don't know that force that they use to push each other, but I can solve for it by summing the forces in the x direction on the child. We know that that force in the x direction, which is from the parent, must equal the mass of the child times the acceleration of the child. They gave us both of those values, so now I have the force that the parent put on the child. Well, that value has to equal the force that the child put on the parent. Equal and opposite. Notice it's in the opposite direction. Now I can solve for the acceleration on the parent. So I sum the forces on the parent. I only have one. It's in the negative direction. I know the mass of the parent, and I'm looking for the acceleration. I can then take this equation and plug in values, rearrange for acceleration, and I will find the acceleration of the parent to be negative 1.06 meters per second squared. And it makes sense that the acceleration is negative because the parent is accelerating